Curiosity Mars rover took this image when it was overlooking a shallow depression called Yellowknife Bay, which is in the left third of this image in the middle distance. Yellowknife Bay is a 5-meter geologic depression located in the large impact crater known as Gale Crater. The Mars Reconnaissance Orbiter has observed morphological features created by the presence of liquid water at this site, suggesting the presence of an ancient lake which could have sustained microbial life here. Perseverance rover captured this amazing video of Phobos, which is one of the two moons of Mars eclipsing the Sun. It's the most zoomed in, highest frame rate observation of a Phobos solar eclipse ever taken from the Martian surface. Several Mars rovers have observed Phobos crossing in front of the Sun in the past. Spirit and Opportunity made the first observations in 2004, and Curiosity in 2019 was the first to record video of the event. Each time these eclipses are observed, they allow scientists to measure subtle shifts in Phobos' orbit over time. The moon's tidal forces pull on the deep interior crust and mantle of the red planet. Studying how much Phobos shifts over time reveals something about how resistant the crust and mantle are, and thus what kinds of materials they are made of. It's long been known that Phobos is drifting towards the Martian surface year by year. Tens of millions of years from now, it is expected to crash into the planet or fragment into chunks that will impact the planet. Studying Phobos' orbit also allows scientists to refine predictions of when the doomed moon will crash into Mars. This image shows a rock outcrop and blocks of rocks in an area called Citadel. Perseverance rover has collected many rock samples from this site. Scientists think sedimentary layers stacked on top of one another on this hill could have been formed by a deep, fast-moving river. But uncertainty about their formation remains because the layers are exceptionally tall by Earth's geology standards to have been created by a river, as some stand up to 66 feet high. This image taken by HiRISE shows the surface of Mars covered in ice. Although the season was late spring when the image was taken, carbon dioxide ice still covers much of the surface at this high latitude site. The temperature at the time was a negative 128 degrees Celsius. The weak boundaries of the polygonal structure of the surface here has been eroded by spring sublimation of carbon dioxide as energy from the sun turns ice to gas. The larger troughs in this image accentuate the surface polygonal structure, while the narrow cracks show the erosion caused when carbon dioxide gas escapes from under the seasonal ice layer, carrying fine material from the surface. The dark fans in this image are made up of small particles from the surface deposited on top of the seasonal layer of ice. These fans originate at a crack, a weak spot that allows the gas to escape. The material is deposited in a direction determined by the direction of the wind as the gas escapes. This is an iron meteorite, which is about 2 meters wide left to right. The smaller piece in the foreground is also an iron meteorite. You can also see angular shaped cavities on the surface of the meteorite. One possible explanation for this is that they resulted from preferential erosion along crystalline boundaries within the metal of the meteorite. Another possibility is that these cavities once contained olivine crystals, which can be found in a rare type of stony iron meteorites called pallasites, thought to have been formed near the core mantle boundary within an asteroid. Iron meteorites are not rare among meteorites found on Earth, but they are less common than stony meteorites. On Mars, iron meteorites dominate the small number of meteorites that have been found. Part of the explanation could come from the resistance of iron meteorites to erosion processes on Mars. This image shows the wall of a scuff mark Curiosity rover made in a wind-blown ripple of Martian sand with its wheel. The upper half of the image shows a small portion of the side wall of the scuff and a little bit of the floor of the scuff at the bottom of this image. The prominent depression which raised rims at the bottom center of the image was formed by one of the treads on Curiosity's front right wheel. The largest grains in this image are 1 to 2 millimeters in size. Those large grains were on top of the wind-blown ripple and fell down to this location when the scuff was made. The bulk of the sand in the ripple is smaller, in the range below 50 to 200 microns. The full scuff mark is 20 inches wide, which is the width of Curiosity's wheel. This view shows a hillside outcrop with layered rocks within the Murray Buttes region on lower Mount Sharp. The buttes and mesas rising above the surface in this area are eroded remnants of ancient sandstone that originated when winds deposited sand after lower Mount Sharp had formed. The layering within the sandstone is called cross bedding and indicates that the sandstone was deposited by wind as migrating sand dunes. Curiosity rover captured this image while exploring an area called the Clay Bearing Unit. The hills and troughs in this little valley, which is carved between a ridge and cliffs higher up Mount Sharp, almost look like undulating waves. Scientists are trying to figure out how this landscape formed over billions of years. At present, the clearest takeaway is that the clay bearing unit is softer than the ridge and that the former has eroded into a valley between the ridge and Mount Sharp while the ridge has resisted erosion. This is the first borehole drilled by Perseverance rover on Mars, which is 2.7 centimeters in diameter. The image was taken by the rover's Watson imager, which can document the structure and texture within a drilled target, and its data can be used to derive depth measurements. The image was taken at night in order to reduce self-shadowing within the borehole that can occur during daylight imaging. Some of Watson's white LEDs has also illuminated the borehole in the image. These finger-like rocks may look strange, but they likely formed as groundwater trickled through rock in the ancient past, depositing mineral cements over time. Many years later, when the rock was exposed to the atmosphere, wind eroded the softer material around the cemented portions, leaving the rock with this strange-looking appearance. This image taken by Curiosity rover shows an amazing landscape. The rise topped by two grey rocks near the center of the image is called Twin Cairns Island. It is about 100 feet from Curiosity's position when this image was taken, and the two grey rocks combined are about 10 feet wide. This image shows a rock feature at the base of Zero crater. It is a sandstone which is composed of fine grains that have been carried from elsewhere by water before settling and forming stone. Rocks like these are important for study and search for organics and potential evidence of past or present life. These dark streaks, also known as slope streaks on Mars, resulted from dust avalanches. They were captured by NASA's Mars Reconnaissance Orbiter using its high-resolution imaging science experiment camera. Perseverance rover captured this video of Ingenuity Mars helicopter taking its first powered controlled flight on Mars. The rover was parked about 211 feet away when it chronicled the flight operations with its cameras. During this first flight, the 4-pound helicopter climbed to an altitude of 10 feet, hovered and then touched back down on the surface of Mars. Curiosity rover captured this view of the lower stratigraphy at a location inside Gale crater on Mars. In the image, you can see veins and concretions, which are small spherical concentrations of minerals under the rock overhangs. Both veins and concretions strongly suggest precipitation of minerals from water here. This image taken by Mars Reconnaissance Orbiter shows relatively bright mounds scattered throughout darker and diverse surfaces in Chryse Planitia. These mounds are hundreds of meters in size. The largest of the mounds shows a central pit similar to the collapsed craters found at the summit of some volcanoes on Earth. The origins of these pitted mounds or cratered cones are uncertain. They could be the result of the interaction of lava and water, or perhaps formed from the eruption of hot mud originating from beneath the surface. These features are very interesting to scientists because if these mounds are indeed mud related, they may be one of the long sought after sources for transient methane on Mars. The image here shows the location where Perseverance rover deposits its cache of samples, which is located in the distance. A shiny foil piece which is part of a thermal blanket was found stuck on this rock. NASA thinks it came from Perseverance rover's descent stage crash site 2 kilometers away, but aren't sure how the bit traveled so far across Mars. This image taken by Curiosity rover shows rows of striated rocks all oriented in a similar direction in the foreground and the spectacular Mount Sharp on the horizon. Images taken from orbit and used in planning the rover's route toward lower slopes of Mount Sharp had piqued researchers' interest in the striations on the ground that are formed by these rows of rocks. The sedimentary foothills of Mount Sharp is also an interesting destination inside Gale crater because it holds caches of water-altered minerals. This image taken by Perseverance rover shows bright, light-toned outcrops near the Zero crater rim in the upper center of this image approximately 4 kilometers away, with darker toned boulders in the foreground. Scientists have been trying to understand the origin, composition, and alteration history of the massive dark-toned rocks. Challenges abound, however, as many of these exposed rocks are covered in a thick, crusty dust layer that partially obscures the ability to understand their true composition.